Greetings, math fans. All right, so this is the last day of the Harper prep for the final exam. And basically, we're just going to go over some miscellaneous topics. It's all based off of worksheet 7. And some of the stuff you know already, some you don't. It's not that difficult, but it's a lot of little miscellaneous topics. So let's get started here. First thing I want to talk about is, which we all know, is domain and range. Right? Domain are x values, and range are y values. So super easy. If I said points 2 comma 3, 5 comma 8, and negative 6 comma 1. Okay, again, super easy. My domain is going to be just the x value, so 2, 5, and negative 6. Okay, pretty easy. And of course, my range is just going to be 3, 8, and 1. All right, so that's pretty easy, right? I'm going to also ask you guys if something is a function. So the question will say, do the points represent a function? So really what you have to do here, math fans, is you are going to ask yourselves, does x repeat? Okay, if no x values repeat, then it's a function. Okay? That's pretty much it. If no x values repeat, then it's a function. It's super easy. So actually the points that I just wrote out here now, that would be a function because it's 2, 5, and negative 6. No repeats. So this is an example of not a function. So not a function. If I said 2 comma 8, 3 comma 7, and 2 comma 16, okay? Because you got the 2 is repeat, so that would not be a function, okay? It doesn't matter about y values. So if I had something like, 2 comma 5 and 8 comma 9 and 6 comma 5. So you see the y values repeated, that's still a function. It's just the x values cannot repeat. That's important. X values can't repeat. Y values can repeat. So speaking of that, you can actually do it with a graph as well. So graphs are functions if they pass the vertical line test. So remember, vertical line is up and down. So an example is if I gave you a graph that looked like this, and I draw any vertical line, it only hits at one place, the graph. One place, one place, one place, one, one. So you would say, yes, that is a function. Okay? An example where it doesn't is if I gave you something look like this. Okay, because again, you would go, okay, well, that's good, that's good. Oh, that's not good. In fact, it's crossing in more than one place. Okay, so this would be no. It's not a function because it crosses more than one place. Okay, so that's how you do it with a graph as well. Pretty easy. Okay. All right, so let's kind of move on here. Another question that you're going to be asked is just going to say, is 2 comma negative 3 a solution to y is equal to 3x minus 8. Okay, so basically what you're doing, it's really easy. You plug it in and see if it's true. That's all. It's a yes or no. So I plug as a y is negative 3 and x is 2. So 3 times 2 minus 8. Okay, so you get negative 3 equals 6 minus 8. And again, use it your calculator, I don't care. Anyway, you get 6 minus 8 is negative 2. And it is not equal to negative 3. So the answer to this question is no. That's all you do. Pretty easy. Okay. All right, so let's talk a little bit about function notation. So function notation. You guys have seen this before. F of x is equal to 2x plus 3. G of x, I can use any letter I want. G of x equals negative 3x plus 1. Okay? So if I said, what's f of 4? You just put a 4 in where the x is. So it's 2 times 4 plus 3. And guys, I don't care, you use your calculator. Type it in exactly the way you see it. 2 parentheses 4 plus 3. So it's 8 plus 3, you get 11. Super easy. Okay? So that's a pretty easy one. Just put that number in there. So let's say if I said something like f of x times g of x. That just means you multiply the two together. So it's 2x plus 3 times negative 3x plus 1. And you FOIL it. So 2x times negative 3x is negative 6x squared. 2x times 1 is plus 2x. 3 times negative 3x is negative 9x. And 3 times 1 is plus 3. Combine like terms. So negative 6x squared minus 7x plus 3. That's your answer. Okay? So that's not bad. Let's keep going here. I'm going to actually erase this because I want to keep those values up there. So I can give you another problem that looks like this. F of x minus g of x. Now I want to tell you the notation that looks like this. F plus g of x. This is the same. Oh, sorry. This should be a plus here. Sorry. Okay, so f of x plus g of x. If it looks like f plus g of x, that's the same thing. So you're just adding them together. So it's going to be 2x plus 3 plus negative 3x plus 1. And that's easy. So it's 2x minus 3x is negative x. 3 plus 1 is 4. That's the answer. Okay, I could also say f of x minus g of x. Or I could say f minus g of x. The same thing. So I subtract them. So that means 2x plus 3 minus negative 3x plus 1. Okay, don't forget to distribute the negative. It's important. So you get 2x plus 3 plus 3x minus 1. Okay, that gives you 5x plus 2. Okay? So just kind of recognize the notation. Again, it can either look like this or it can look like this. Same thing with this guy here. It can either look like that or like that. Okay? So that is function notation. One last thing to cover, math fans, is inverses. Okay, so let's talk about inverses. So basically, an inverse is, let me just do an example. Actually, I'll give you f of x equals 2x plus 7. So what you need to realize is, let's write this as y, because it works a lot better. So if I write y equals equal to 2x plus 7, it's easier. And then what you do is you swap the x and the y, and then you solve for y. That's all you do. That's how you find the inverse. Swap the x and y and solve for y. So if I swap the x and y, I get x equals 2y plus 7. Okay, let's solve for y now. I'm going to subtract 7. So 2y equals x minus 7 and divide by 2. So y is equal to 1 half x, or x over 2 minus 7 halves. That's the inverse of that function. Okay, it's not bad. Let's do another one. So how about f of x is equal to 5x minus 9. Okay, so again, I'm going to write it as y is equal to 5x minus 9. And then I'm going to swap the x and the y. So x equals 5y minus 9. So now I'm going to add 9 to both sides. I'm solving for y. So 5y is equal to x plus 9, and then divide by 5. So y is equal to 1/5 x. And if you said x over 5, that's the same thing. Plus 9/5. That's your answer. That's the inverse of that function. Now, it can get a little more complicated when you have a squared. So let's do that. So if I said f of x is equal to x squared plus, I don't know, plus 6. So I'm going to write it as y is equal to x squared plus 6. Okay, and then I'm going to swap the x and y. So x equals y squared plus 6. So I'm going to solve for y squared. So I'm going to subtract 6 from both sides. So you get y squared equals x minus 6. And then I take the square root of both sides. So y is equal to, and don't forget, it's plus or minus, x minus 6. And that's all you can do. That's your answer. Okay? So that's actually pretty easy. Now, let me just do a problem almost identical to it, but I'm going to do x cubed plus 6. So same thing, y is equal to x cubed plus 6. I'm going to swap the x and y. So x equals y cubed plus 6. I'm going to subtract 6 from both sides. I'm solving for y. So you get y cubed equals x minus 6. And then I take the cube root. So y is equal to the cube root of, and here's the deal, math fans, there's no plus or minus. If it's an odd power, there's no plus or minus. If it's an even power like this, you got plus or minus. That's important. So write that down someplace. Okay, so there's no plus or minus, just the cube root of x minus 6, and that's it. That's your answer. Okay, so that's basically worksheet 7, guys, and then we're going to take a practice final to hopefully get you guys ready for the Harper final coming up. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.